Hi everyone, myself Mr. Santosh Mudar, Assistant Professor in the Department of Physics, the S.G. Balekandi Institute of Technology, Belagavi, Karnataka. Today I would like to take you to perform the experiment torsional pendulum, and here for this torsional pendulum, so what you are going to determine, so we are going to determine the modulus of rigidity of the wire and the moment of inertia of the disc. So what is torsional pendulum? So it consists of a thin metallic wire and one end is suspended with a solid metallic circular disc and other end of the wire is suspended to a rigid support. So this constitutes the torsional pendulum. Now our aim is to determine the modulus of rigidity of this wire and moment of inertia of a circular disc. So for that, what is the procedure and how it can be performed, I will explain now. And you can see the diagram for this experiment, and the formulas required are two formulas. One is I is equal to mr square by 2, where m is the mass of the disc, r is the radius of the circular disc. And so by calculating this moment of inertia of the circular disc, and you have to use this value in the formula of modulus of rigidity, which is given by eta is equal to 8 pi I, so divided by r small r raised to 4 into L by t square. And here the I is the moment of inertia, what it is calculated in the earlier formula, that can be substituted, and small r is the radius of this thin wire, and L by t square is obtained from doing the experiment from the tableau column, where L stands for the length of the wire from here to from this end. So this is the length of the wire, and then T is the time period. So now the tableau column you can see here, tableau column, and the record of observation. So in the record of observation we find some values given there. So the radius of the wire is given, and the radius of the disc is given, and the mass of the disc is given. So using those values you can calculate the moment of inertia. Now we shall see the tableau column. So in the tableau column, so we find only for two lengths we have to take the readings. So one is for 0.3 meter and one is for a 0.5 meter. So for any one length, so once you know the procedure, the same thing is repeated for the other length. Now we shall see for the second length here 0.5. So this is of a length 0.5 meter. So now what you have to do is, so first you have to give a twist for this metallic disc, and you have to count the 10 oscillations. So what is one oscillation? Suppose if you consider these two reference points, I will take one reference point here. So that reference point, suppose here this reference point where I kept the finger there, and if it is coming to the one end in clockwise direction, again it is moving back to the initial position. So this constitutes one oscillations. So now when you give the twist for this disc, so like this only the pendulum, torsion pendulum start oscillating. So then you have to count 10 oscillations. So like this only, after counting 10 oscillations, so once you start counting the number of oscillations, at the same time simultaneously you should start the stop clock. So once you complete counting the 10 oscillations, at that moment you have to stop the stop clock. So how much time is taken for 10 oscillations to complete? So that time is entered in the tableau column as a T1, small T1, right? So immediately again for the second trial, for the same length, the second trial and the third trial should be carried out, and the same procedure is repeated. And once if you want to start the second trial, again you see that the stop clock is reset or not. So if it is not, reset the stop clock and then so start the experiment. So suppose if you count the 10 oscillations there, 10 oscillations, so that enter the time taken here, T1, and similarly you repeat the experiment for 2 more trials, and thereby by taking the time as T2 and T3. Later, so for entering all the trials timings there, take the mean of these time periods for 10 oscillations. And later what you must do is, so take the average of these T1, T2, T3, and thus you have to calculate the time period for one oscillation. So whatever the time period is taken here, it is for 10 oscillations. Now you require to calculate the time period for one oscillation. That is called the time period of a torsional pendulum. So that is formula is given by capital T is equal to small t by 10. That gives you the time period for one oscillation. And after calculating the time period, so you have to calculate t square. Square the t and find out the t square. And t square is here and the length of the wire is here. Take these two values and find out L by t square for one particular length. And similarly, the same procedure is repeated for another length. And whatever you can find out the L by t square, take the mean of those two L by t square and put the value here at the bottom. And this value of L by t square is taken and substituted in the formula given eta is equal to 8 pi I by r/4 into L by t square. So to calculate and determine the modulus of rigidity of a wire. And once you calculate the moment of inertia and modulus of rigidity of a wire, so with SI in it, you should enter in the result column. So in the result, modulus of rigidity of a wire, that is equal to, so Newton per meter square, and moment of inertia of the circular disc as a I is equal to dash kg per meter square. Kg meter square. So this is what it is about the torsional pendulum experiment. I hope you understand. So if thank you very much.